So we've had a look at the assignment operators, and recall that they are mostly used as shorthand for programmers, just a shorthand for things that are done often. And there's always the slight bonus that the program runs a couple of milliseconds faster. Now, increment and decrement operators are used for exactly the same reason. They're even more of a shorthand. They're, if you like, a shorter shorthand. And this is what they look like. They are the minus minus and the plus plus operators. If you think about it, that's where C++ came from. It's an increment of C. So the plus plus is the increment and the minus minus is the decrement. Okay, I haven't really told you how they work yet, so let's have a look at an example. X equals y plus z plus plus. Okay, what's going on here? Well, the plus plus, as it applies to z, means that z gets incremented. Increment means that 1 gets added to it. Exactly 1, and always 1. So whatever z was before this line of code was executed, after the line of code is executed, z has increased in value by 1. Now obviously x is also going to change value here, but this is interesting. You can see that something on the right-hand side of an equal sign is actually changing. That's exactly what's happened. It's not a shorthand for z plus 1. It's actually changing z. So, let's do some numerical examples here. So, if y is 1 and z is 2, then x is probably going to be either 3 or 4, isn't it? It depends on whether the incrementing of z happens before or after the assignment is done. So which is it? Well, in this particular case, it happens afterwards. Only in this particular case, and I'll explain that in a second. What's happening here is that y and z are added together and the result is put into x. And after that, z is incremented. That's the order that things happen. So I'll show you another example, slightly different, almost the same. X equals y plus minus minus z. Now, what's going on here? Well, the minus minus is a decrement, so z decreases by 1. That's the first thing that's different. Now, I don't want you to assume that because the minus minus is in front of z and the plus plus is after z, that that's the way things always have to be around. Because it's quite possible to have them the other way around. You could have a plus plus z or a z minus minus. They work as well. So you can have the plus pluses either before or after the variable. You can have the minus minuses before or after the variable. And it's precisely the placement of the increment or decrement operators before or after the variable that governs when the increment happens. Does it happen before the assignment or does it happen after the assignment? Now you notice in the first example I said that the increment happens after the assignment. Y equals 1, z equals 2, x got the value 3, and after that z got incremented from 2 to 3. Now in the second example, the increment happens before the assignment. It happens before the assignment because the minus minus is placed before the z. That's exactly the way it works. So if y was 1 and z was 2, then it would be 1 plus, the very first thing that's going to happen is that z is going to be decremented. So z will go to 1. So it will be 1 plus 1, and the value of that will be put into x. So obviously x will be 2. So as you can see, the position of the increment or decrement operator relative to the operand is really very crucially important. It is actually possible just to have, say, on a line by itself, z plus plus, semicolon. Just that's it. That's the whole line, z plus plus, semicolon. And then it doesn't really matter whether it happened before or after, because the result of the line is that z gets incremented. So it's almost like saying before or after what? There's only one thing happening. The increment is the only thing happening. Similarly, you could have minus minus z or z minus minus on a line by itself, and it wouldn't really matter. It only matters when there's an equal sign on the same line. Or more specifically, if something else is happening on the line after the value of z has been read, or before the value of z has been read, as the case may be. Anyway, let's go and have a look at some examples. This is increment.c in the Chapter 8 folder. And we're going to print out the values of x's and y's and z's. And let's just give z a value to start with so that it actually prints out something sensible. Okay, now y equals 5, x equals y plus plus. Okay, so we're going to then do a printf. What's going to be the value of x and y in the printf? Well, I would imagine that y is going to be 6 because y has been incremented. That's the first thing. It's pretty obvious y has been incremented. But the question is, what's the value of x? Because is it going to be incremented before or after the value of y is taken out of y and put into x? Can you remember? Okay. The plus plus is after the y, therefore the increment happens after the assignment. So the increment happens last on the line, so y, the value of y, 5, will be put into x, so x will be 5, and then y will be incremented. Let's check that. And no errors, and run, and yes, indeed, x is equal to 5, and then after that y gets incremented. Good. Okay, let's do it the other way around now. Plus plus. It's actually possible to leave the line, to leave the line exactly like that. That is a valid line, plus plus y plus plus. That will compile. The very first thing that will happen will be that y will get incremented, then the value of y, which would then be 6, would be put into x, and then y would be incremented again. So y would go to 7. So y would be incremented twice. You'd end up with a value of 7 for y, and x would be 6. Let's check that. Oh, this compiler doesn't like that. Now that's odd, because most compilers do like that. Okay, well I'm not very impressed by that, but that is a perfectly valid thing to do in C. Anyway, let's just go back to what we were going to do before, which was this. Okay, and now y is still going to be incremented by 1, and the value of x is going to be, have a think about it while I compile this. Is it going to be 5 or is it going to be 6? What's your bet? It's 6. Now why is it 6? Well, because the increment happens first, so y goes to 6, and then the assignment happens second, so x goes to 6 as well. Okay, so let's move on. Let's make this now 6, and this time we'll do z equals x plus 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 y. Whoa! What is going on there? That will actually compile. It really will. It's legitimate and valid C code. However, I did a little practice run before this, and I discovered that this compiler doesn't like it. This compiler gives you an error message. Now, that's not standard. I've seen this compile beautifully on different compilers. So I suggest that you type that piece of code into a compiler and run it and see what you get, because your compiler might be perfectly okay with it. And I found that the way to fix this is put a little space in there. If you think about it, what's really happening is this. We're doing an x plus plus, and then we're doing a plus, and then we're doing a plus plus y. But remember, spaces are not significant in C, so we can actually get rid of the spaces and do that. Or at least we should be able to. This compiler doesn't like it. So the question is, what is going to be the value of z? Well, let's break it down a bit. Now, firstly, the very first thing that's going to happen is plus plus y. So y is going to go to 6. The next thing that's going to happen is the addition is going to happen, because remember, this plus plus happens last. So we're going to have a 6 here, and a 6 here, and that's 12. So z will be 12, then x will get incremented as well, x will go to 7. So both x and y get incremented to 6 and 7, and z will be the value of 12. Let's check that. And that is indeed correct. Okay. So I'll save this for you now, but I'll save it in that form so that you can compile it yourself like that. Okay, so hopefully now we've got a pretty good idea of the concepts behind these increment operators. Now let's go and see them used. Let's see a typical practical use of the operators. I'm going to open up a file called increment2.c. Okay, this is increment2.c, which was actually the 18 by 18 multiplication table from an earlier exercise. Remember this one? Okay. Now, the reason I've chosen this one to demonstrate the plus plus operators is because this contains a bunch of for loops. And for loops are the perfect place. In fact, they're probably the most common place that the plus plus operator is used. So, and I'll show you where. Remember I said that this bit of the for loop is called the increment. And that's exactly what we're doing. We're incrementing I by 1. Now, there's two ways that we could make that shorter and faster. The first way is we could say I plus equals 1. I plus equals 1. That's perfect. Well, it's perfect, but there's something that's even more perfect, if there is such a thing, and that's just I plus plus. You know, isn't that nice? So we can do that with all of these. And let's just make sure that that compiles and runs. And run, and there's our 18 times tables. Lovely. Okay, so it's a very, very simple process to use these increment and decrement operators in place of I equals I plus 1 and so on. And they do actually make the programmer's life a little bit more convenient. They enable you to do things in far less lines of code than you might otherwise expect. In fact, when I was preparing some of the previous exercises, I found myself writing I++ in loops like this. And then I had to remind myself, oh, hang on, we're not up to that yet. They don't know those plus plus operators yet, and take them out. Because I'm just in the force of habit of doing them, and you will be too as soon as you get into programming in a proper way. Anyway, let's have a look at another example. I'm going to open up now increment3.c. Okay, increment3.c. Now, this program is a simple string copy program. Well, let's see if that's exactly what it is. We enter a name, read the name. Now I'm going to copy name into name2. Name into name2. And print out the results of name2. Let's first check that it works. Run, enter your name, mark, and name2 is mark. Okay, so it's clearly working. I want you to have a look at this bit of code right here. Can you see what's going on? You're probably firstly confused by this bit of code, while name I. Well, what does that mean? Well, it's certainly not a Boolean. This is an ugly piece of code. I don't like it myself, so I'll fix that up the way I like it. While name I does not equal 0. In fact, I'll take it one step further. This is the way I really like it, because this is not ambiguous at all. \0 quote. Okay, so now we're saying while name I is not the null character. So whatever character in the string we're currently up to, we want to check that it's not the null character, and if it's not, we can keep going. And so that means, of course, as soon as we reach the null character, we stop the while loop. Notice that I has been initialized to 0 before we go into this. And now we go name2 I equals name I, so we're copying that character into that character, and then we're incrementing I. Notice that it is I++, not ++i. If we did ++i, then the index value I would be incremented by 1 before we actually copied from here to here. Now that's awfully confusing. In fact, this whole line of code, I don't like it. This whole construction of code is a little bit unreadable. It's probably very efficient. It's even more efficient when you do this. But efficiency and readability don't necessarily go hand in hand. And I always opt for readability. That might sound odd, especially from the point of view of somebody learning a language. Efficiency? Surely efficiency is the most supreme virtue that a program can have. And I'd argue, no, that's not the case. And if you knew how many millions, or in fact trillions of dollars are spent around the world every year on code maintenance, then you would probably rethink that. Commercial programming is all about money, thus the name commercial, as in commerce. And more money is spent in software development on maintenance than on anything else. So if you can cut down maintenance costs, then you are saving a great deal of money. Or in other words, you're making a great deal of money. I'm up on my little soapbox here. Maintainability is the absolute strongest virtue that a program can have, assuming, of course, that the program actually works. cleverness and efficiency are lovely things to have as long as they don't come at the expense of readability. And readability is a big component of maintainability. Anyway, you've heard my opinion on the matter. Get back to this piece of code. I just wanted to show you this because it is the sort of thing that people do quite a lot. And when you're reading somebody else's code, you need to be able to read this and understand it. So I hope this is now explained for you.